Dixie State University offers a course in artificial intelligence. This course introduces the broad field of artificial intelligence and computer software. Over the course, students work on AI for a virtual scavenger. For the first section of the scavenger, the students must create an AI that will make the scavenger traverse the world safely and search for a goal point. In the second section, AI is created to search out specific objects in the world, collect them, and deposit them back at base. For the final section, AI is created to allow the agent to learn which objects are desired. Agents operate by giving specific commands to the server. The server then sends back a percept to the agent so that they can decide what is the next action. Also, the server sends the information to the display so that the user can see what course the agent is taking. In the current setup, the user receives information from the server in a terminal. This information includes all the information about the agent's status, as well as the information about the current location of the agent. This information can fly by very quickly, making it difficult for the user to truly see what is occurring with the agent. The display offers a bit more organized information. Each cell in the display is shown as a color. This color represents the elevation of the cell. Bordering the cells are lines. These lines represent the interface between the cells. Green represents plains, brown represents mud, grayish-green represents rock, black represents walls, and light brown represents cliffs. The agents are represented by colored dots on the screen, and the colored slashes through the squares represent where the agent has been. Finally, the number in the cells represents the number of objects at the location. The problem with this display is that it can be a bit difficult to decipher quickly. For example, the elevation coloring is difficult to tell what cells are higher, which causes the agents to use more energy. On larger maps, the agents seem to disappear. It can be so difficult to locate them. And the interface between the cells at a quick glance can be difficult to tell what is what. For example, both rocks and plains are green, just different shades. My focus in my schooling has been graphics programming, so I wanted a capstone project that demonstrates what I've learned throughout the last few years. So for my project, I offered to create a new display that offers students more information about their agent, allowing them more time to be spent on programming the agent and less time trying to figure out what it's actually doing. This new display creates a 3D representation of the world. This eliminates the difficulty of determining cell elevation differences, as well as allow the user to easily see certain terrain features like cliffs and walls. To demonstrate the other terrain features, I have also added textures and models to represent them. Rocks are now represented by actual rocks the user can see, and mud and plains are represented by grass and mud textures. Agents and the bases are also represented by 3D models. The agents are represented by a 4-prop hover drone. To help discern what the agent is doing, I've added animation for each of the actions it's able to perform: moving, looking, examining, picking up, depositing and dropping, charging, and even death. These animations are there to help the users actually see what their agents are doing without having to search through large amounts of output. Along with the animations providing information about the agent, I have also provided a full heads-up display for the agent information. In the bottom left of the display, the user is provided with the information about the agent's current action, the amount of objects at the current location, the amount of objects the agent is carrying, the amount of objects at its base, and finally the location of the agent. In the top left are instructions to the user on how to use the display, and in the top center it displays the name of the current agent program we are looking at. In the top right, we have a battery that displays the agent's current charge, and on the right we have a health bar displaying how much health the agent has left. And finally, in the bottom center, we have a running total of the agent's performance. The controls for the display are meant to be simple and meant to be able to be operated with one hand. The user is able to rotate the camera around the map or an agent depending on the current camera mode. The user is also able to zoom the camera in and out. The user also has the ability to turn the grid on and off, as well as highlighting, allowing them to see where the agent has been. If the camera mode is set to the world, the user will see where all agents have been, and if the camera mode is set to follow an agent, it will only display where the specific agent has been. A couple of the challenges I ran into while working on this project was the terrain generation and server display communication. The terrain generation provided a challenge because the information fed to the display about the world was slightly two-dimensional. For each cell, I had to break it up into 8 triangles and calculate each vertice's height based on the surrounding vertices. The cliff provided a specific challenge because of the elevation. Also, because the terrain is based on a file generated with non-modeling programs, I was not given normals or texture coordinates. As such, I needed to calculate each of these on the fly as I generated the terrain. The next challenge was to overcome the server display communication. The previous display would only update when the server provided it with information. While this is effective enough for a two-dimensional display, for a three-dimensional display I needed to have the display not rely on the server. So to overcome the challenge, I had to look into multi-threading. While I had done some multi-threading in Go, I had not done any in C++. I had to do a lot of research into how it worked. Overall, the project was a great success and provides the users with a lot more details on what their agents are currently doing. Hopefully, the users will now be able to spend more time focusing on their code and less time deciphering large amounts of output.